Protocols refresher. So, as we talked about so far, and this is very critical to understanding Wireshark, understanding the specifics of network analysis, is the basics of protocols and what that really means. So, the fundamental knowledge that you need to do and work with, that you need to know and work with Wireshark is something that has to be hard pressed, because when you work with Wireshark and you troubleshoot issues, if you're not understanding what protocol is, or how to gather information about protocols, and how to further analyze the data that you accurately capture, um, you're not going to be able to really decipher what may be broken, and what the problem may be. So in order to pinpoint or to place, what the actual problem is, you're going to need to quite possibly recreate the problem or capture the problem as it's happening, and know what protocols to look through, and understanding how the data traverses the network, what devices it travels through, what protocols the devices are using. So a good example would be, just as a basis to start with, if you're troubleshooting a problem on a network, and you have a wide area network, and you have a group of routers using EIGRP, uh, are you going to capture the EIGRP traffic, and are you going to understand what those packets reveal when you look at it? What is EIGRP? What's normal for EIGRP? Those are the types of things, when we talk about protocol refresher, is something that is important to understand, and what it is that you're going to need to study for on the exam. So as we read through the syllabus, we covered a lot of different protocols, but primarily understanding how they work from a source to a destination is the key here. So understanding that when you fire up a client and you want to access a server on the network, a couple of things to understand: are they using wire to wireless? A good issue that, or a common issue that may come up is, well, I'm wired into the network, but I also have my wireless card turned on. Is that creating a performance impact? Is it sending traffic out both interfaces? Are you only using wireless, and is that access point overwhelmed and causing contention, and you're not able to get good throughput when accessing the web server, as an example, or the database server? All the way to understanding that when you actually booted up that computer, you had a process where the MAC address needed to resolve, and you needed to get an IP address. So you're using ARP, you're using DHCP. Let's say you wanted to access that web server by name, and it's using DNS. Is DNS in use? If DNS is being used, does that mean that it's definitely using UDP? The answer would be yes, unless you're doing a zone transfer on TCP. So understanding how these protocols work, and what you're doing, and the traffic flow, and the concepts of sending data from a source to a destination or multiple destinations, is absolutely critical to using this tool. And as we mentioned earlier, and it seems to be something that at least I find myself whiteboarding when working with clients or customers quite often, is this OSI model to explain what's happening when you're sending the data from source to destination, and what that actually looks like when data is captured. So a quick example could be if I was just capturing data, and I'll do a very quick one here, and I specifically wanted to look at an ARP packet. It's very interesting that there's no IP header. So if I was going to draw this on an OSI model, I would have only gotten up to layer 2, whereas layer 3, the network layer, would have showed me the IP address. If I wanted to look at an HTTP packet, what does that mean as far as what headers I see? And those types of things directly map to what I'm talking about here in the OSI model in the 7-layer diagram. Understanding that type of flow of traffic, very important to understand what protocols operate on what layer. Now, those types of questions don't manifest themselves directly on the exam, but an understanding of it is important to be able to work with the capture for the exam. As well, it's very important to know for day-to-day work. So this is where I hope these concepts kind of collide for you, where you learn something like the OSI model over many years of doing this type of work, and then you say, well, I'm interested in working with Wireshark, and then you start working with it, and then lo and behold, you're confronted with having to understand or having to hear about the OSI model again. But hopefully this kind of opens that up to you to show you in the actual capture itself, what does that actually mean as far as data being encapsulated and the headers, and what do you see within the headers, and how do you troubleshoot problems working with that data. So I have here very simply a simple network diagram to show you basically how understanding protocols is important and relevant to using Wireshark. So on a simple segment here, I have a laptop connected into the switch. I'm going to use that as my computer to capture data with Wireshark, and I'm going to look at the conversation from the client to what I have here as a database server. It's on a local set of segments. It's not traversing a router. It's not going over a WAN. It's a very simple conversation. But what do I really need to know as far as protocols? What am I looking for? So a good question would be, what's going on the server? What's the actual server doing? And this may be something that you need to talk to the server administrator about if you're not that person as well. But if I am going to plug into a Cisco switch, I'm going to span ports, I'm going to capture data from a client talking to a server. Specifically, what am I filtering on? What am I looking for? And a good question would be, what's the problem that's indicated? So the client may say, well, when I access a database, it's very slow. Well, there's a lot of things that could be. Is it the fact that the network that you're using to connect to the database is problematic? Is what you're pulling down too large? Or is there an I/O problem on the server itself? And interestingly, with using the things that we're learning about, using timestamps and time values, and looking at TCP retransmissions as far as how many times it was requested the data, and that's really what's important here to understand as far as the capture itself. And one thing not to rule out is to actually have all of these things checked as well, to make sure that, for example, the client has enough, has the appropriate resources to use what it's trying to use. So, for example, if it's a 100 meg connection, it really should have a gig. Is that an issue? You could see that through troubleshooting, but that's something that you might be able to find out. Does it have enough memory? Is there a virus on the computer? And or looking at the server itself, is that server problematic? Does it have an I/O problem? Does the database need to be indexed? All of these types of things is what makes an expert analyst, as far as not just using Wireshark as the tool itself, but understanding the complete picture or the scenario of the problem that's been presented. But again, just to bring it back to the protocols, you would need to understand what protocols are in use here, and also what ports. So as an example here, we may see traffic trying to connect port 1433. It might be trying to use SQL. There may be a problem where we might identify specifically that in this case it was an indexing problem. We saw that the network didn't show any real issues at all, but it was a problem with the actual server itself. But again, you would definitely need to capture, save, and analyze those files to have been able to determine that you could rule out the network itself and know that you did not have a problem, and or you did have a problem, and why. So again, a lot of concepts revolved around that network diagram. There's a lot of things that could have happened here. For example, you may have improper cabling. You may have a problem where the client was trying to access via wireless and it wasn't giving the correct bandwidth, or the access point, there was contention of some sort, some type of layer 1 issue with electrical signals or the cabling itself. The layers 2 through 7, you may actually have some serious data flow problems where you have contention on the network. Your local area network links are too small or overwhelmed. Port channel is overwhelmed, or it's only taking one of the links due to preference, and you mistakenly think that you're using 2 gigs and you're only using 1. You may have a WAN link that is particularly overwhelmed. You do not have the appropriate bandwidth, and or a backup or a large data transfer was taking place. There's a lot of things that happen layer 2 through 7, all the way up to the point where the application just doesn't work well on the network because it's using a lot of small packets, and instead of normal sized or within MTU packet size packets, and it might be overwhelming buffers. There's a lot of things that happen between 2 and 7, and understanding how the protocols work, how the layers work, how all of these different things play together is going to help you to be able to better read a capture and be able to rule out certain things just based on these simple concepts. And again, very big for the exam, but and also big for your day-to-day work is understanding specifically port connections. Is it using the correct port? Is it a well-known port? Those types of things. As we already mentioned, you may have an issue where you have a bandwidth problem. You may see a lot of retransmits. You may see an overwhelmed host with a buffer full condition, and or a windowing problem where it's not adjusting on an appropriate size window. This may all result in slowness or the inability to send data accurately, and what that might manifest itself is in a bandwidth issue. But by using Wireshark, you can capture these other types of information and be able to show there was appropriate bandwidth, however, there was incorrect windowing, as an example. The buffers were overloaded. You could have data corruption. You may have an asynchronous routing condition. There may be latency just due to the type of data that you're sending, and or because you don't have or you have too many hops. So as an example, you may be going from New York to California, and there just may be a little bit of extra latency, extra milliseconds, just because it's going over X amount of hops instead of, for example, going from New York to New Jersey. There's many reasons, but when you capture the data, you can quickly rule in or rule out many of these conditions. And again, important to understand that there's a very important way to capture your data is to understand that you can't just walk into a network and they say, I have a problem with the server, and plug that protocol analyzer just about anywhere to capture that data. You're going to have to know what the source computer, the complaint computer is, and or what the receiving computer, the recipient, or the destination host is, and be able to map that out and place your analyzer accurately. And it's almost always likely that you're going to be spanning a port and capturing that data that way, because although it's pretty common to install Wireshark on a client computer, it's not always allowed or appropriate to install Wireshark or applications on, for example, a database server. This may be something that is, since you're testing something that may still be in production, without downtime, installing an app and incurring more I/O and memory and disk space usage may not be the best choice or allowed. So you would have to know where to place your Wireshark